The concept AMG GTX is a bold statement. More than a show car, it is a technology demonstrator, a glimpse of the high-performance, fully electric future envisaged by Mercedes-AMG. From the moment the car's exterior was revealed, it becomes clear this is not a modest step forward, but a leap, an electric four-door performance machine that follows in the footsteps of the AMG GT lineage, but one that changes the rules. Some may call it audacious, others inevitable. Either way, the GT XX sets out to redefine what AMG performance means in the age of electrification. Visually, the car draws on motorsport heritage and futuristic design in equal measure. Its fastback silhouette, low-slung bonnet, and wide stance speak of classic performance instincts. At the same time, the detailing is unmistakably from the modern era. Active aero features, ultra-low drag coefficient, high-tech lighting elements, and wheel designs that double as aero devices. The design achievement is not simply aesthetic. Every contour, every vent, every blade moves air, cools components, reduces drag, or generates downforce when needed. For example, the drag coefficient is claimed at 0.198, a figure that underlines the aerodynamic ambition. The exterior is not purely about looking fast. It's about being efficient at speed. Underneath the bodywork lies the next-generation architecture from AMG, the so-called AMG DEA, AMG Electric Architecture. This is not simply a repackage of existing EV components. Instead, it represents an approach designed from the ground up for high-performance electric vehicles. The GT XX is the first public demonstration of that architecture, meant to preview the future series model from AMG. That architecture includes a new battery system, new electric drive units, advanced cooling and thermal management, and a vehicle platform optimized for all-electric high performance. At the heart of the drivetrain are 3 axial-flux electric motors. 2 are mounted at the rear, packaged into a high-performance electric drive unit, HPEDU, together with a planetary gear set and inverter. The third motor sits at the front as a boost motor and offers additional traction when required. The rear motors capable of powering the rear axle deliver the bulk of the performance, while the front motor joins when needed. The decision to go axial flux rather than traditional radial flux motors is significant. Axial flux designs offer higher power density, quicker response, more compact packaging, and improved thermal efficiency. Mercedes-AMG states the motors are significantly more compact and lighter than conventional types, enabling a low center of gravity and packaging advantages, critical for a performance car. The combined output exceeds 1,000 kW, in some publications stated at about 1,360 horsepower, or 1,000 kW, enabling a top speed of over 360 km/h. The car is described as an all-wheel drive layout via the front motor plus rear motors, with a system which under typical driving may favor rear-wheel drive, but engages the front motor for acceleration, heavy loads, or extra grip. The torque distribution is fully variable. The propulsion system is more than simply powerful. It is engineered for sustained performance and repeatability, rather than just peak bursts. Equally critical is the battery system. The GT XX uses a high-performance electric battery, HPEDU, developed in the context of AMG's own high-performance initiatives, and derived from knowledge in Formula One and the AMG 1 hypercar. The battery uses tall, slim cylindrical NCMA, nickel, cobalt, manganese, aluminium cells with silicon anodes, housed in a laser-welded aluminium cell container, and uses direct cell cooling via non-conductive oil, a novel approach allowing very high charge and discharge rates while maintaining thermal stability. The energy density of the cells is claimed at around 300 kWh at the cell level, which is quite high for a performance-oriented, zero-emissions vehicle. Importantly, the system is designed for extremes: high sustained output, high continuous loads, and ultra-fast recharging. Mercedes-AMG claims the battery system can achieve an average charging power of more than 850 kWh, and some sources record over 1,000 kWh peaks during charging sessions. In practical terms, the GT XX is said to be capable of adding enough charge for approximately 400 kilometers of WLTP range in just 5 minutes when a suitably powerful charger is used. This kind of charging performance is unprecedented in production or near production vehicles and signals the direction that AMG believes is necessary for true performance EVs. The chassis and structural aspects also reflect the overarching ambition. Lightweight materials, composites, aluminium and steel mix in the body in white to deliver high rigidity and low mass where possible. The wheel and aero systems demonstrate a motorsport-inspired mindset. For example, the GT XX uses 21-inch forged aluminium wheels with active aero blades. Each blade is individually controlled via mini generators mounted in the hub and responds to driving mode or brake cooling demand. The underbody features a Venturi effect diffuser, active AR panel louvers, and other advanced cooling and airflow management systems. Even the tires and materials inside the cabin show technical ambition. Sustainable biotech, leather alternatives, 3D printed ergonomic seats, exposed body structure in parts of the cabin, minimal visual distractions, and performance-oriented controls. Inside, the driver-centric cockpit is lean but rich in detail. 2 large integrated screens, instrument cluster and infotainment, are mounted in a seamless glass frame. The steering wheel takes a race-inspired shape. The center console uses exposed structural extrusions that emphasize the electric architecture. For example, illuminated orange pipes symbolizing high-voltage conduits. The materials selected reflect both luxury and performance. Carbon fiber components, molded seats with 3D printed pads, surfaces made from recycled GT3 racing tires turned into vegan leather alternatives, and a minimalist roof liner that leaves the carbon fiber structure visible. The aesthetic is restrained, technical and purposeful. No unnecessary adornments. Every feature speaks of performance. But beyond the specification and engineering numbers, the GT XX is also about performance validation and demonstration. In August 2025, Mercedes-AMG took the GT XX, in prototype form, to the legendary high-speed track at Nardo Ring in southern Italy to undertake an endurance run under extreme conditions. A team of drivers covered 40,075 kilometers, about the Earth's equator, in 7 days. 13 hours, 24 minutes, and 07 seconds, i.e., around the world in 8 days. During this period, they averaged over 300 km/h in some publications and established no fewer than 25 long-distance records. The test included long-duration high-speed driving, sustained loads on the battery and motors, repeated fast-charging sessions, and minimal downtime. The aim was to prove that an electric performance vehicle could handle far more than short bursts, that it could endure, sustain, recharge, and not compromise under real-world stress. This achievement acts as a statement. Electrification is no longer just about clean energy, it is about sustained high performance. The GT XX's role, then, is twofold. First, it serves as a flagship concept of what AMG will deliver in its high-performance electric machines. Second, it acts as a technological testbed. Axial-flux motors, high-density battery, ultra-fast charging, active aero wheels, sustainable materials. Many of these items are claimed to be destined for series production as part of the AMG GEA platform, starting around 2026. In other words, this concept is not simply a styling exercise. It is a preview of engineering direction. From a dynamic performance perspective, the implications are substantial. With a peak output in excess of 1,000 km and top speed beyond 360 km/h, the GT XX situates itself firmly in the hyper-performance category. But more than that, the architecture targets everyday usability. That ultra-fast charging capability means less time stationary, more time on the road, a key barrier to EV adoption when performance is required. The design philosophy here acknowledges that a performance EV must not only accelerate, but also handle, brake, corner, sustain high speed, recover quickly, and do so repeatedly without compromise. In terms of market positioning and brand strategy, the GT